Vishwas Patil. He will be talking about evolving role of PKIs in facilitating trust over the internet. Dr. Vishwas Patil is a senior research scientist at the Department of Computer Science and Engineering, IIT Bombay. His current work focuses on various research aspects in cybersecurity of critical infrastructure, privacy in linkable datasets, modern payment systems, blockchains. Biswas is a PhD from the University of Rome and is an alumnus of NIT Surat. He has been associated with Tata Institute of Fundamental Research as a scientific officer and with A-Star Singapore as a scientist and as a security analyst with BNP Paribas Bank Singapore. Sir, over to you.
Thank you. At the back, okay. So today we are going to talk about a couple of things related to PKI, of course. So what I'm going to take you through is what expectations the PKI was started, where it is, what are its some drawbacks, and what alternatives that people are trying to either complement or uh, build a parallel to the PKIs. So this is the presentation about an open thing, that whether there should be only one technology or multiple technologies. So we'll come to that at the end. So first I'll cover the problems that current implementation of X509 has. And the task that X509 came up with is these four things that X509 protocol has to satisfy. It has to create the certificates, store them, distribute, and revoke. So that's called as certificate management. And in a wider term, it can be also termed as key management, because certificates are dealing with keys, public-private keys, the asymmetric key types. So this is nothing but a systematic step of things that one has to do if one has to deploy a PKI. So there are standards, and people know how to deploy them. So there are private implementations, open source implementations, and they gel well with each other because of the standards. So a certificate is an analogy, a digital certificate is actually an analogy of the real world certificates that we have usually. So there is an issuer and there is a recipient. The issuer vouches for the recipient for particular things. But in 1988, when these standards were proposed, the intention was to vouch for someone's identity. So the identity could be was to establish someone's public key that you want to widely distribute across the internet, so that with your private key you can establish who you are. The invention of digital certificate came, and to distribute these digital certificates, this protocol came. So a digital certificate is nothing but a binding between an issuer and the recipient, and it is signed by the private key of the issuer. And such set of files are stored somewhere called X500 directory, and they are efficiently distributed across the internet. There could be more than one such issuers, and they are called as certificate authorities. And they issue something like this that is not legible, but in your browsers you can open any certificate or SSL keypad, and if you see the certificate detail, you will see something like this. But this example is something typical, in which what you are seeing is, this is an Amazon certificate, and Amazon has been issued a certificate, and it shows who are its parents. So it has not been directly issued by a global CA like VeriSign, etc., but there are one intermediary CA. And this is a special certificate in which Amazon single key is not entrusted, but a range of names about Amazon like AWS, etc., have been authorized to represent as Amazon brand. So I don't know whether you can see this notation. Keep in mind this notation. This is nothing but a CA is talking about some entity. So this is a digital certificate. This is a notation for a digital certificate where someone is vouching for some identifier. So here it is Amazon. So we'll use this notation here onwards. So this is a standard component-wise view of a PKI infrastructure where there is a CA, there is a registration authority, there is a validating authority who gives the certificates to web servers, etc., and there is a user who wants to authenticate itself with the end user. So what we are doing over here, so I said digital certificate is an analogy of real world certificates. So here there is some real world user who wants to get a digital certificate so that with this digital certificates, this real world user can establish his or her identity across the internet. So there is a natural entity, and now we are converting this entity into a legal entity or a virtual entity. So this legal or virtual entity can go across the internet and establish its identity. In real world, with real certificates, we have limited jurisdictions. Jurisdiction means about the enforcement of law. Whereas here in the virtual world, the jurisdiction is across the world, and laws are not the same across the geographies. In real certificates, we get the certificates usually from trusted anchors like governments. We elect them, we then derive the trust from them. Whereas for virtual world, we convert these credentials into some sort of representation or tokens, and then we start using them. So the question now I ask you is, since all of we use SSL certificates in our daily browsing life, when we open a browser and we see that whether some site is secure or not, by the way of looking at the symbol, whether it is green or gray or red, and at some point we also see some additional characters beside the lock symbol. For example, if it is Microsoft website, it says Microsoft Corporation. Similarly for Google and other big players. So these are called extended validated certificates, where they pay higher fees and the validator asks for some, sorry? I'm not hearing you. Don't close the speaker. Too close. Yeah, I was mentioning about extended certificates. So my question to you is, if assume you are getting a certificate by showing some additional proof and your certificate is getting green color, let's say, and that green color has some, let's say, everyone trusts that better, or you get some priority because you have that green color, then there is an incentive that you will provide whatever credentials are required to get such a certificate. And large corporations, usually in retail sector like Amazon, they do such an extended validation because they want their users to verify them better or trust them. Now the question is, assume we all are looking for extended validated certificates so that we get some privileges or elevated validation. So assume in India, if we are getting an extended validation certificate by showing our driving license, and in some other country where driving license is very strict, you have to actually drive the car, you have to actually follow certain things, and if you don't, then your card gets revoked. So in that country, also their citizen also get the extended validation certificate by showing their driving license. So question to you is, which EV certificate is uh, actually extended validated certificate, because the underlying certificate, the physical certificate that we are providing, is flawed in one geography and it is perfect in another geography. But over the internet, we are treating all these certificates as fine. Right? So this is the problem we are entering into. So PKI is meant for entity identification. It could be users, it could be devices, it could be softwares, anything. So we need entity authentication. So that's what PKI were invented for. But the problem is, in real world, we have laws related to geographies, but over the internet, we don't have such distinction. So we are going to talk about what people are doing to address such things. So here, in my presentation, all these green slides or green fonted slides are observations. So we are going to summarize them at the end. So first observation is we do not have uniform global criteria for identity. It could be for users or it could be for devices or softwares. And we are building digital identities for a global scale. So when a digital certificate is presented over the internet, this kind of flow happens between the verifier and the entity for which the certificate is being verified. So there is a root at the top and there is a certificate at the bottom, and iteratively whoever has issued the certificate and the issuer, that way the verification goes all the way to the root. So if you open up your browsers, any of these browsers, what you will see is there is a set of root certificates. They come pre-built in retail machines, but in private organizations, the organizations may decide to change them. So these are called root certificates. And if you want to verify a chain, you have to have a reference. And that reference is this set. And this set is called as root trust store. And usually in our mobile devices, operating systems, and browsers have different trust store, OS has different, mobiles have different. You'll be, it's worth opening these trust store and seeing what kind of certificates are there. And you will be, can you raise your hands if SHA-1 is still safe? No, right? So you'll be surprised to see there are still certificates, root certificates used using SHA-1, and they are still valid. So not all browsers, some browsers, at least Firefox has 2. So this is, and how many times do you open these certificates and check? So what I'm trying to highlight is we are trusting, not blindly, but we trust because we are not seeing any adverse impact on us. And we are finding that it's going fine, your bank balance is as you expect and other things as you expect, you order, it comes. So there is no suspicion that you have. But, and this is how we humans get trained and we start not investigating what is happening under the hood. As I said that there are at least 2 root certificates with SHA-1, even I am surprised. While preparing this presentation, I came across this. And there could be some technical reasons behind that for some other entities, but not for general population. So we are trusting these electronic devices and softwares 100% for our online operation. And what is happening over here is in this figure, if Alice wants to speak with Emil, they have a path. If there exists a path through a common voucher, that is the root has vouched for org1, org2, and later on org1 has vouched for department 1 and Alice. So there exists a path from Alice to Emil, therefore they can speak with each other through some common intersection. Whereas Emil has, with this figure, Emil has 2 options to prove itself, herself to Alice with 2 potential paths. what if in this situation Emil has only one path, though Emil has two certificates? The thing that we want to highlight over here is we don't check how our certificates are getting verified. Though Emil had two options to send to speak with to authenticate with Alice, Alice never opens up the browser and checks with which root CA this certificate has been validated. And another thing that happens in PKI is cross certification. So the entities that are allowed to issue certificate, for example here org1 and org2, they can issue certificates to each other, and that is called as cross certification. So here with that angle bracket notation, what you can see is these are two CAs, these are also CAs. If you see that they have issued certificates to each other. Whereas here, this cross certification example, X has been issued a certificate by its parent W, similarly Y. X has issued a certificate to parent, that's fine. And then X has issued a certificate to Z, which is another CA. And Z has issued a certificate to X. So these two CAs have issued certificates to each other, and this is called as cross certification. This is happening in the background. We never open up and check what is the chain looks like. So the claim I want to make is, and this is what you see, either green, red or nothing, that the trust decisions in the current protocol that we use are binary. They either we get green color or we get red color, and that's all what we that's all we are trained to use the current PKI for security. And actually it was designed for authentication only, but later on it has been, currently we use even for authorization. We'll come to that. So we are making two observations. One is the decisions are binary, trust decisions. Second is the primary objective of X509 PKI was only authentication. That is, there is a issuer, there is a recipient, and the issuer is saying, I know this recipient. Therefore, if you trust me, you can believe this recipient. But with the propagation of IT in our daily life and in organizations, there are several instances where we require confidentially across devices, across network, which though under your control, but they require, and that's where we again need a PKI type of infrastructure that helps key management. So PKI is a digital certificate creator, store, issuer, and revoker. In a broader term, it is a key management system. So as we are entering into explosion of devices around us and penetration of IT in organizations, the role of key management is ever important. And we see instances of private PKIs doing key management for local jurisdiction, and we use several other secure systems that are not integrated with our browsers, but they are also PKIs. They are also at global scale, like banking, though MasterCard and Visa are root CAs, telecom, satellite TVs, and enterprise Wi-Fi's. So these are instances of X509 PKIs that are in practice. And with these examples, I want to highlight that authentication is used as an implied authorization. If you have this, you are authorized to do that, things like this. So the role of PKI from authentication has moved towards authorization in certain use cases, and it's And I'm not saying that it's going beyond that, but it has problems over there to move beyond that, and we'll come to, when we cover the alternatives, we'll discuss those things. So to summarize the role of PKI, PKI is authentication system, service provider, but we are using it for authorization also, and it has inherent problems in its steps, protocol steps. That is, in creation it has issues. For example, this e-mudra, it allows you to get a certificate in India to file your digitally signed documents to the government, and it has two options. One, you pay 3,000-4,000 and you get a key pair issued, generated by e-mudra. The other option is 30,000-40,000, I guess, in which they give another two options. That is, either they will generate the key for you or you can submit the CSR to them. So how many of us really do this CSR business? No one. So it's always that the issuer is taking you for granted. It's not granted, but legally they are restricted somewhere. But this is a very key thing, that someone else is generating the keys for you, and that is becoming your identifier, for which the private key is potentially in the control of the generator. So how you create the certificate is also important. How you store the certificates is important. Distribution of certificates is problematic. If you see the browser settings, you will see that your browser may not be enabled for certificate validation for each site. So there is a protocol called OCSP which mandates the browser to check a digital certificate for its validity at this point, and only if it is valid, the secure connection has to be established. And the problem with that is, if everyone starts doing that, then there is a huge load at the certificate distribution point. And with one certificate revocation, the whole thing requires a large amount of updates, because the millions of certificates are issued and they need to be maintained and told to their users which one is valid, which one is not valid. And revocation, the purpose is either through expiry or through some incident, the certificate should be revoked and should be mentioned in the CRL database. But there is a common practice in Android app development and many other software places like containers or Kubernetes, for to skip the complex part of key management, certificate management. People integrate with their code the keys. So this is called as certificate pinning or stapling. Okay. There are valid things, but this is deprecated now, but these are the issues that PKI has. So what people have been doing alternatively? So these problems are not that they are coming to fore these days. People are aware of these things, and people are aware of the way hierarchical PKIs has trust issues. So people tried alternatives like PGP. It is as old as X509, in which users A, B, C, if A knows B and B knows C, there is a high chance that B will introduce C to A. So it's up to A whether to trust C via B. There could be another path for A to reach C via D. So these kind of decisions end user has to make and write in its local key store, so that next time the end user wants to send an email or receive an email, a proper trusted value is or path is chosen. There is another effort around 2000 which is called as Spooky, in which instead of issuing a certificate to an explicit key, you can issue a certificate to a string, and that string can be later evaluated into keys. So for example, here with this, assume this CA has issued Amazon key, which is a traditional way of issuing X509 certificate. Whereas assume now we have the facility to define this string in which the subset are key 1, key 2, key 3, again strings like India, EU, USA and AWS. For Amazon, it is very important, which has millions of devices under its control, and key management has to be extremely efficient, revocation has to be in real time. So for that purpose, they would like to, it's not practical for them to issue millions and delete thousands, something like that. But a nice way would be to segregate country-wise resources, service-wise resources, and whenever time requires, they can evaluate these strings into actual keys. If something has been deleted from Indian side, assume at this moment, and then we evaluate what is India is equal to, you will get the current value under India string. So that is the intention under Spooky, in which assume you delete key 1 and now evaluate what is Amazon, you will not get key 1 in the evaluation. So that way Spooky allows you to issue certificate which are valid for long time, because you have issued the certificate to a string, and that evaluation has to be done when you are using the certificate. So this way you save yourself from revocation. Someone else does the revocation. Whoever owns this string Amazon is responsible to do the revocation, and the certificates can stay for longer duration. So X509 is a hierarchical trust model where root is at the top and the end user is at the bottom, and the end user has no means to verify whether someone else is impersonating that end user's identity, because there is a chance that if there is a CA which has been hacked or compromised, the CA can issue a similar certificate for the end user, and there are instances that have happened in the past. So in its journey of almost 30-35 years, X509 has been extended 2 times. So currently we are using version 3, in which you are allowed to define additional attributes which you can mark either as critical or not critical. If it is critical, the user of the certificate must make use of these attributes. So that is the thing. So with this, a lot X509 or ITUT, the body behind it, tried to give a fresh lease of line or fresh what you say capability to X509 certificates to be more expressive, because until version 2 it was just a data structure which was stating this is the issuer, this is the receiver, and this is the validity period. Whereas in modern certificates you can get very useful extensions and also undesired problems because of those extensions. For example, in this example, this is an example with SAN certificate, which is subject alternative names, in which the certificate is issued, let's say google.com, it can say mail.com, doc.com, spreadsheet.google.com. All these subdomains are part of google.com. So instead of asking different certificates for all these domains, Google asked a single certificate to root CA, providing a list of such names. So this certificate is valid across all of its services. So that is SAN. Similarly, there is another option of star wildcard certificates, in which the left hand side of the fully qualified domain name is under your control. We spoke about certificate pinning, right? So mobile apps, digitally signed softwares, hardware devices like Cisco devices, etc., they come pre-installed certificate which implicitly say that you must trust this hardware, and also a lot of IoT deployments fall under this. So alternatively, as I was mentioning about this X509 retrofits and the extensions to this protocol, there are other efforts like Etsy is doing. So people who joined the workshop on 7th of this conference, there was this discussion going on where Etsy representative was telling us that across EU, all the around 27 member states are providing their guidelines. For example, I gave you the example of driving license, right? So the equivalence of credentials across the geographic things, and they come to some understanding, some policy, and all these countries are then building a collaborative route or a trust anchor for European Union and trying to push this trusted list in the browsers so that there is no single point of failure. All 27 are responsible. They have negotiated what is trusted, what is not trusted, what is acceptable, what is not acceptable, under what conditions when you are in a particular country. So this is called as trusted lists concept, which they are pushing to put in the trusted store where, for example, the browsers that we use. So again, in that presentation also the question of equivalence was raised, which we discussed some time ago about the driving license as a credential across geographies. Okay, so that is the thing that X509 does not allow us to play with. So it is a very rigid data structure. It has in version 3 some extensions, but again the utility of those extensions is limited. For example, in 2009 we played with one extension in which we tried to import the benefits of spooky extended namespaces like the string converting into actual keys. That extension we wrote for X509, and we showed that it X509 can be extended for authorization, for actual authorization, not implied authorization. So apart from the extensions and the limitations that X509 has, X509 also came across some serious trust compromise issues in recent history. So DigiNotar, the root CA, got compromised in 2011, started issuing certificates for Gmail and targeted a particular country's users, and the hack was successful. So, and the targeted users had no clue whether they have been impersonated or being tricked into unwanted situation. So the thing with traditional root CA business is, if something in between gets hacked, you have no idea whether someone is impersonating you. So X509 community or the users of X509 community are the big users of the community, like AWS, Cloudflare, Google, and some CA like DigiCert started this new service called Certificate Transparency, which is specified in RFC 6962. And the initiative is, if someone issues a certificate, it has to be time stamped and it has to be told to 3 or more than 3 notaries in this certificate transparency initiative. So in this example, Cloudflare's Nimbus, Google's Argon, or DigiCert's Yeti. So what they do is they are open, they have open databases. If you participate in this project and if you issue a certificate, you have to send a copy to these databases. So these are open databases, you can query them, you can take a look at which are the certificates that have been freshly issued or revoked or amended. So if you have a doubt about a certificate, you can either go to CRLs, that is a perfect revocation information, and if you have a doubt whether someone is impersonating you and somehow that impersonated certificate has come to you, you can cross check who has issued it. So this certificate transparency data can be padded with OCSP information. That's how currently it is being deployed. So it is a you may say this is a extension to X509 practices to safeguard the end users. What other researchers have been doing? So I am going to propose 4 or 5 prominent ones, and one of those research proposals is the certificate transparency. So DANE is one such approach which relies on DNSSEC. So DNSSEC is taking control of your own domain through cryptographic means. So either you rely on X509 and then build your DNSSEC, or if you are a root CA, you are free to act like a CA. You can have your own key pair and start signing from the root downwards. So similar to X509 roots, there are roots in DNS protocol also. So DNSSEC is a protocol which ensures that your domain is not hijacked. And DANE is a approach in which it allows domain owners to specify which CA is allowed to issue a certificate for a particular resource. So assume if I have resources like web apps facing the internet or some other devices facing the internet, I can explicitly say, or particularly this is used for mail servers. So if I have a mail server which is listening on TLS port, and when it presents its certificate, it has the capability to also say that you should be looking for a certificate issued by blah 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 issuer. So that kind of explicit text records you can mention in the DNS record. Perspectives is another such approach. The analogy is there are notaries across the network, and these notaries are maintaining a copy of certificates which they have observed, and if there is a targeted deviation in certain portion of the network, it will be highlighted if you ask the notaries across the network whether they know this particular digital certificate that you are using. So it's nothing but the clock towers which you can refer to for credibility of the information. Convergence is an extension of perspective with the help of DEN or DNSSEC. And this is the one which got converted into the Certificate Transparency Initiative. So its full form is Multiple Endorsing Certificate Authority Infrastructure, which is nothing but that Cloudflare, Google, DigiCert opening up their databases and listing append only certificates to tell the world that which current certificates have been issued or amended or revoked. So these are the things that are being investigated in X509, either to mitigate the inherent flaws, architectural flaws it has, or the flaws that the administrators do with the infrastructure. So another thing that we are not very concerned about through this protocol is privacy. So every transaction either through our mobile or browser, almost 90% traffic is encrypted now. That means it uses some sort of digital certificate. And in order to use that digital certificate, if your browser is enabled for OCSP, it is going to ask for its validity status with the CRL distributor. And when you do, if assume I am opening my email, mail.google.com, whether the certificate is valid or not will be asked to the CRL. So the CRL knows at what time I am asking this information. The CRL also knows at what time I am asking it for Amazon.com. The CRL also knows for other browsing activities I do and at particular what time I do. So the OCSP servers have this huge log about the certificate users and the domains. So at what time and what domain someone is looking the information for is present in OCSP logs. So the observation is the OCSP logs at CRL servers have end user privacy violation potential. I'm saying potential because so far there is, the good thing about X509 protocol is, and the reason behind we still continue with this protocol is, this is the service mostly given by private enterprises across the world, and these are the legal entities who take the ownership of their actions. So if, for example, RBI, when it mandates its banks that they must use blah blah bit number, bit sized certificates or some particular algorithms, they go and ask a CA for these certificates. So entities are exporting their accountability obligations to someone, but it is a obligation, someone has to do that. So the CAs are in business because they legally give this in writing that if something goes wrong, they are responsible for those things. So we haven't seen any privacy violation of such logs, is probably because they are not supposed to do, or they are not supposed to monetize these logs, etc. Another observation is the recent certificate transparency initiative, which we just spoke about, the Cloudflare Google DigiCert initiative. It exposed identifiers of internal resources of organizations that were supposed to be private. So this is negligence on the user side. So it's not protocol's flaw. So the service, the certificate transparency is supposed to log whatever comes to it. So can we avoid trusted third parties? So this is another approach that people have tried, in which what they do, they rely on X509 initially, and at some point they agree and generate a sovereign key, and that becomes the root anchor. So that they declare that that is the root of their trust, that point onward. So that is, this initiative is based on DNSSEC, and it also maintains a append only data structure. So there are parallels between the blockchain ledgers, which are also append only data structures, and this initiative, and it tries to check whether PKIs can be avoided or the trusted third parties can be avoided. So it is a consortia kind of model. There are several such models, for example, Ripple blockchain, which is again a consortia based validation model. So a proposal is floated around the world, people join that idea, and then they take the ownership of that idea, and they are in control of the trust for that particular protocol. But we use it for authorization also. X509, despite its flaws, is in business because it gives some sort of legal guarantees to its end users. Whereas the other alternatives, we don't see such a thing. Otherwise, X509 would be under what you say, it could be replaced if someone gets such a service. But for authentication, we know Kerberos protocol, we know OAuth, we know OpenID. So these initiatives also exist, but they are not part of our day-to-day transaction the way X509 is prevalent for key management. So if you see, in past 2 years of pandemic, etc., the work from home and the demand for VPNs or the cloud infrastructure, etc., things have drastically changed, and there is a huge demand of IT infrastructure to be deployed. And someone says that 61% of companies are deploying more cryptographic keys and digital certificate. And it's not a surprise that these numbers are going to get increased with the advent of IoTs and other things. And Kubernetes kind of Docker containerization kind of approach, where earlier only one machine was handling one application. Now hundreds of small containers are responsible for such softwares. So several open source and proprietary protocols, or you can say platforms, are available. Some of them are here, but some of the interesting platforms that are coming to questions the dominance of X509's authentication service is the blockchain based frameworks. So Hyperledger Indy is one such initiative, Sovereign is another, and WWW Consortia's DID and verifiable credential is another such systematic initiative in which they allow us how to write identifiers not only for users but resources, services, etc., how to interpret them and how to verify them, how to take ownership of our organization's namespace, etc. So these are systematic ways, kind of very close to the way X509 protocol operates. But the drawback of X509 protocol is it was designed at a time when the requirements were simple, and we have entered into an time arena in which the requirements are so ephemeral or so short lived and so conditional that it is difficult to express all these policies in certificates. So the question is, can we think of something in between? So X509 is great as a backbone for key distribution, but poor in specifying policies for those keys, where it should be used and etc. kind of things. So blockchain based protocols like the ones that I mentioned and many others are filling up this space of expressiveness, where you can write smart contracts, you can say which resource should be available to which end user at what under what conditions, either payment or conditions. So these are the things that we are seeing around in this business of authentication and authorization. So coming back to the question of privacy, so X509 and the certificate transparency, I mentioned the logs have the potential to violate end users' privacy. What happens in a blockchain based platform, which are typically open or semi permissioned platforms, where the policies, the credentials, the conditions all are open. So it is a transparent way of expressing your policies. So we cannot criticize it as a privacy violation because we have expressed it that way, knowing that these are open systems. And the advantage of blockchain based platform is you can maintain your own local ledger and you can query it locally. So to ask something you don't need to go out, which is the case with CRLs. So the issue of privacy remains. So this question of whether we can have something in between X509, which is rigid, and something flexible. So we tried to address this question in one of our paper titled Trust Management for E-Transactions, and we named this proposal as FlexiACL, in which we allow the end user to write policies like this. So this is a skeleton of a policy in which we are mentioning that there are two ACL blocks and the quorum is set to 1. What does this mean? The one who wants to satisfy this policy has to either satisfy block 1 or block 2, at least one. So that is the meaning of quorum is set to 1. If quorum is equal to 1 is not mentioned, you must satisfy both the blocks. So we provide a language, you can use these constructs of our language and write expressive policies. So now let's get into the individual rules that one can use to write a policy. So the example of the rules could be things like this. So there will be a type of the rule, like on this slide you are seeing 3 types of the rules. One is spooky, one is TCP/IP wrapper, one is a plain token, something like ERC20 in Ethereum. But this paper is written in 2005. Okay, so at that time we coined this notion of cryptographic tokens, which can be offline verified and can be used as a proof. So in this example of rules, the first rule says if it is of type spooky, and it says my collaborators can delegate a permission. So who are my collaborators? My collaborators is a string. The actual keys are not mentioned. So if you want to evaluate the actual keys for this, you have to if you read the spooky protocol, in which the facility of evaluating strings into keys is given. So we make use of that. So that is the example of spooky. The second example might be very common for you, which is of TCP/IP wrapper. On a Linux machine, in a host.allow or host.deny, we write such wrapper rules and which decides which type of IP address traffic can reach your machine. So in this, subnet 16 for this particular IP range is allowed to access this service. So the other type of access control mechanisms that we use in our day-to-day life can be incorporated into this language called FlexiSCL. You can build blocks, you can write quorums on top of blocks, and that way this flexible expression of authorization policies can be written. So to recap, the observations that we made were, we do not have a uniform global criteria for identity representation. So that's the problem we have with X509 digital certificates. We treat all certificate as equal over the internet. But in the background, these certificates are obtained with different credentials. And we are building a digital identities for global scale. In X509, trust decisions are binary. Authentication is the primary task of PKI, but we use it for authorization also. And so with these observations, the question that for which we don't have answer, and that's why we keep on coming across several new proposals for authentication and authorization, either based on blockchain or some other consortia based initiatives. So PKI is someone, when I was reading, is like a bicycle which needs repair, but you can't stop and you can't repair when you are driving it. So we have come to this stage. PKI is showing signs of fatigue because we are expecting that it should do more work beyond authentication and authorization, but it cannot. It was designed for something else. And the other technologies do not command this kind of rooted trust, means what PKI has built over past 35 years. So the question still remains open, and we have discussed the potential of our framework in building such a trust management service. So FlexiSCL is our language using which you can express policies for trust management, which is based on PKI and other access control rules which you can use. So with this, I thank you all for listening to this talk.
Thank you, sir. So I will request Dr. Balaji to felicitate the speaker. Please. Yes, sir, sure. So we'll start with the paper presentations. So our first paper presentation theme is PKI in IoT environment, and the session moderator will be Dr. KK Sondra Pandian from the Office of CCA.
Thank you, Anup. Let's start the paper presentation with the theme of PKI, public infrastructure in IoT environment. This session would be very much interesting how the PKI solution is going to interact with the IoT devices. So as all you know, the IoT is going to be a big, massive impact towards the today's environment. How the security, because as of now, no IoT device is secured. So how do you want to integrate the IPK solution into the IoT device? So that's a challenging as well as a remarkable research which is still going on. So let's hear up the speakers with the different participants from other areas of research. I call upon Mr. Improved PKI Certificate Lifecycle Management with Centralized Device Management for Industrial IoT. The author is Ashwin Krishnan, Satish Rajender, and Sunil Kumar. Is there an online they are joining? Anu? Huh? Yeah, 1 second. Over to the author.